In our next couple of videos, we're going to learn about a special type of function called an inverse function. And we're going to see that if you're given a function that meets certain characteristics, you can find an inverse function to that function. And we're going to see that an inverse function is a function that undoes what the original function does. So we're going to look at some of these concepts with some ordered pairs, with some very basic functions to get down the concept of what an inverse does, and also to learn about the concept of a one-to-one function. And then in our next video, we'll look at finding the inverse of more interesting functions. So let's say that we have, and this should be a little bit of a review of what we did in our first lesson, functions, but I'm going to go ahead and quickly go back over that to make sure it's fresh in your mind. So I'm just making up a relation here, just literally making up numbers and putting them in here. 2 maps to -1, -3 maps to 5, and 4 maps to 1. And we can see that this is a function. It is a function because each x maps to exactly 1 y. And we can see that our domain, actually I'm going to have you do this. Go ahead and pause the video, list your domain, list your range, and then turn the video back on. Oh, also, before you do that, before you turn the video back on, go ahead and plot all 3 of those ordered pairs. So go ahead and do both of those things and then turn the video back on. All right, remember that our domain is our values of x. So our domain in numerical order is -3, 2, and 4. And our range is -1, 1, and 5. And because this is a function, we could have written each of these in this form. F of 2 equals -1, f of -3 equals 5, and f of 4 equals 1. And when we plot each of those, we have x is 2, y is -1. When f is -3, x is -3, y is 5. And I have this ordered pair. And then when x is 4, y is 1. And we have this ordered pair. So these 3 points on the graph, these 3 ordered pairs, and these 3 function value statements all give me exactly the same information. And I'm going to need a little more room here to do what I'm going to do next. So I'm going to go ahead and rewrite those real quick. A little further over. All right, so now what we're interested in here is the inverse function of f. And we're going to call that f inverse. So when I see this little -1 up here, that's not an exponent. I would read that as f inverse. And that means the function that undoes what f does. What f does is it maps 2 to -1, -3 to 5, and 4 to 1. So what f inverse is going to do is it's going to take that -1 back to 2, the 5 back to -3, and the 1 back to 4. So in other words, if I rewrite these ordered pairs, I'm taking -1 to 2, 5 to negative 3, and 1 to 4. This is also a function. Each x maps to exactly one y. So I want you to write the domain and the range of this new f inverse function. And I want you to write the function notation, and I'll do the first one here. F inverse of negative 1 equals 2. And I want you to plot each of those ordered pairs. And I can do this using a different color here. But if you are just taking your notes in one color, then use a different, a star or a box or something to differentiate between the 3 points that are in F. So pause the video, rewrite each ordered pair as function notation, write your domain, write your range, and plot those other 2 points. And when you're done with that, turn the video back on. All right, so we see that the function f inverse of 5, my x, equals negative 3. And f inverse of 1, my x, is equal to 4. So my domain are the x values, the numbers I'm starting with, negative 1, 1, and 5. And my range are my y values, the numbers I'm ending up with, negative 3, 2, and 4. Now notice what's happened here. Between f and f inverse, the domain and the range are always going to have a specific relationship. And it's going to be the domain of f is the range of f inverse, and the range of f is going to be the domain of f inverse, because what I literally did was just switch my x and my y. And if I plot each of those ordered pairs, let's see, 5, negative 3, and 1, 4. These are my 3 ordered pairs. Now I want you to see the relationship here. When I switch my x and my y, if I were to put a line here, right down the diagonal, and that's the line y equals x. Notice my relationship here. I have a mirror reflection across that line. This point mirrored over to here. This point mirrored over to here, and then this point mirrored over to here. And that will happen every single time that you have a function and its inverse. They will be a reflection across this diagonal line, x equals y. Let's look at another example with ordered pairs. Let's say that I have the ordered pairs. Let's call this G. 3, negative 2, 0, 4. And again, I'm just making these numbers up. They don't have any specific meaning or anything. I'm just saying 3 maps to negative 2, 0 maps to 4, 1 maps to 5, and negative 1 maps to negative 2. All right. First thing we need to determine is this a function? Does each x map to exactly one y? So write down on your paper whether this is a function or is not a function. We see here g of 3 is negative 2, one answer. G of 0 is 4, one answer. G of 1 is 5, one answer. g of -1 is -2. One answer. So this is a function. Is a function. One way to tell that this was a function was that each of my x values are different. They do not repeat. Now, some people might have answered that this was not a function because we see here that we have a repeating y. But that's okay. It's all right if the y repeats. Only the x cannot repeat. So if I were to graph this, if I were to plot those ordered pairs, why don't you go ahead and pause the video and plot those ordered pairs, and then turn the video back on. And we see that we have 3, -2, and we have 0, 4, and we have 1, 5, and we have -1, -2. And we see this function does pass the vertical line test. I can draw a vertical line anywhere and only touch the graph one time or no times. So this is a function by the vertical line test. All right, let's think about if we were to try to find an inverse of this. If I were to try to find G inverse and I switched my ordered pairs. Notice right here, -2 is mapping to 3, and it's also mapping to -1. That means that this is not a function. Not a function. And we see that this was not a function because we did have this y repeating. So we see that to be able to find an inverse, not only do we have to have the x's do not repeat, we also have to have that the y's do not repeat. So what we're seeing here is that for a function to have an inverse, it must be not only a function, but it must be what's called a one-to-one function. So it must be a function and it must be one-to-one. Let's talk about the definition of a one-to-one function. A one-to-one function is a function in which every x maps to exactly 1. And so far, this is just the same as a function. But here comes our different word. A one-to-one function is a function in which every x maps to exactly 1 different y. So not only do my x's not repeat, my y's cannot repeat either. So let's look back at our picture here. Notice that it is a function because of the vertical line test. But notice right here, if I drew a horizontal line, I am touching the graph 2 times. That means my y is repeating. So to tell if a function is one-to-one, it must pass the vertical line test to make sure it's a function, but it also must pass the horizontal line test to make sure that it's 1-to-1. So if I look back at this function, g is a function, but it does not have an inverse because it is not 1-to-1. And we're going to see in a few minutes, or in our next video actually, we're going to see that to find an inverse of a function, our very first step is to determine whether it is 1-to-1. And we've seen when we have ordered pairs that we can determine that it's a 1-to-1 function by just looking at my x's, making sure they don't repeat, and then looking at my y's to make sure they don't repeat. But we're going to use the vertical and horizontal line tests to tell whether some more complicated functions are 1-to-1. So what I'm going to do is I am going to reproduce some of our basic functions here. Not very good at drawing a straight line here. All right, so we have 6 of our basic functions: linear function, quadratic function, cubic, cube root, square root, and absolute value. And what I'd like you to do for each of these is to go back and to write next to each one whether it's a function, and I'm going to put another one on here. I'm going to put one more on here. This is not one of our basic functions. This is a relation that we haven't looked at. And I want you, for each of these relations that are written, y equals something or x and y something, look at the picture. See if it passes the vertical line test to see whether it's a function or not, and see whether it passes the horizontal and the vertical line test to see if it is a 1-to-1 function. And then write out beside each one, function, not a function, or 1-to-1 function. Pause the video, sketch the graphs, do that, and then turn the video back on. All right, let's look at these. This linear function is a function, passes the vertical line test and the horizontal line test. So this one is a 1-to-1 function. This one is a function. It passes the vertical line test, but it does not pass the horizontal line test. So this is a function, but not a 1-to-1 function, which means we could not find an inverse for it. Then we look at x cubed, passes the vertical line test, passes the horizontal line test. So this one is a 1-to-1 function. The cube root passes the vertical line test, passes the horizontal line test. So it is a 1-to-1 function. The square root passes the vertical line test, passes the horizontal line test. It is a 1-to-1 function. And I'm doing this very rapidly because I am assuming that you have paused the video and done the work yourself, and you are only checking the same work that I've done. So this one is a function, passes the vertical line test, does not pass the horizontal line test, crosses it twice. So this is a function, but it is not 1-to-1. And then looking at this last one, we see that it does not pass the vertical line test. So it is not a function. And it's important to realize that a relation has to be a function already and then also be 1-to-1. So to be a 1-to-1 function, it must pass the vertical line test and also the horizontal line test. All right, so hopefully you have a pretty good grasp of what it means to be a 1-to-1 function and how to determine that. And you also have kind of a basic understanding of what an inverse function does. It undoes what the original function does, and the relationship between the two graphs of a function f and its inverse, f inverse. In our next video, we're going to look at actually a step-by-step process to finding inverses of given functions written in the form f of x equals 3x plus 8 or x squared minus 5, etc. And that's what we'll look at in our next